Hi, so today I'm reading Towards a Human-like Open Domain Chatbot. It's from Google Research. What they did is they collected Reddit discussions, they did some filtering on them, and then they used Evolve Transformer to train a chatbot, which they evaluated as being possibly the state of the art of chatbots. Abstract is following. We present Mina, a multi-turn open domain chatbot trained end-to-end on data mined and filtered through from public domain social media conversations. This 2.6 billion parameter neural network is trained to minimize perplexity, automatic metric that we compare against human judgment of multi-turn conversation quality. To capture this judgment, we propose a human evaluation metric called sensibleness and specificity average. This captures key elements of good conversations. Interestingly, our experiments show a strong correlation between perplexity and SSA. The fact that the best perplexity end-to-end trained Mina scores high on SSA, 72% of multi-turn evaluations, suggests that human level SSA of 86% is potentially within reach if we can better optimize perplexity. Additionally, the full version of Mina with filtering mechanisms and tuned decodings scores 79% SSA, 23% higher in absolute SSA than existing chatbots that we evaluated. So on figure 1, interactive SSA versus perplexity. Each point is a different version of Mina model. Regression line is plotted for which the coefficient of determination R squared is 0.93, an indication of strong correlation between perplexity and human evaluation metric SSA. The dotted lines show SSA performance of other chatbots. Humans 86%, the best end-to-end trained Mina model 72%, and full version of Mina, which incorporates a filtering mechanism and tuned decoding. Section 5, and score 79%. Mitsoku and Cleverbot scored the same on overall SSA, but the Mitsoku displayed higher sensibleness, whereas Cleverbot has higher specificity. See sections 2.5, 2.6, and 4.3 for more details on how we perform these comparisons, how to interpret the results. Alright, so on the chart, I see that the humans do the best, 86%. This is a straight dashed line on the top where the vertical axis is interactive SSA percent and the horizontal axis is perplexity. Okay, human Mina is just below human. Then we have Mina base, and then there's a quite wide gap to the first other chatbot, which is Cleverbot and Mitsoku. And then there is a Diallo GPT. Okay, I never heard of the Diallo GPT actually. Okay, so let's continue introduction. The ability to converse freely in natural language is one of the hallmarks of human intelligence. It's like a requirement for true artificial intelligence. In order to exploit this aspect of intelligence, many researchers are working to open domain chatbots. Unlike closed domain chatbots which responded to keywords or intensively accomplish specific tasks, open domain chatbots can engage in conversation on any topic. Some open domain chatbots like Milabot, Xalo Ice, Gunrock, Mitsoku, Cleverbot display human-like attributes but rely on complex frameworks such as dialect managers with knowledge-based, retrieval-based, or rule-based systems. End-to-end neural network approaches 2016, 2015, 2019 on the other hand offer simplicity of the single learned model. Despite much research, open domain chatbots still have weaknesses that prevent them from being generally useful. They often respond to open-ended input in ways that do not make sense or replies that are vague and generic. We present Mina, a generative chatbot model that was trained end-to-end on 40 billion words mined and filtered from public domain social media conversations. With Mina, we push the limits of the end-to-end approach, show that a large scale of low perplexity model can be a good conversationalist. We use seek-to-seek model 2014 with the Evolve Transformer 2019. So again here they use Evolved Transformer as the main architecture. The model is trained on multi-turn conversations where the input sequence is all trends of the context, and the output sequence is the response. Our best model has 2.6 parameters and achieves text perplexity of 10.2 based on vocabulary of AK words, BPE subwords. Okay. We measure the quality of Mina, specific sensibleness and specificity average. So they want to make sense and be specific. They ask human judges to label response on these two criteria. And our evaluations find that 97 of the human produced statements meet this criteria. However, making sense is not enough. If a model is designed with sensibleness, it's only subjective. Responses could be vague and boring. That is a safe strategy to avoid being penalized for making sense. For example, closed domain chatbots typically respond with generic apology when humans ask something outside of their domain. Some end-to-end learned chatbots respond "I don't know" to many inputs, and Turing text, context, and trends often try to avoid detection by being strategically vague. 2018. They succeed in not generating gibberish or contradicting themselves, but at the cost of not really saying anything in substance. To mitigate this, we add second dimension SSA metric, which asks evaluators whether the response is specific given the context. This prevents the bots from hiding behind vague replies, allowing us to more openly examine what they are capable of. Okay. They compare Mina, our best result. This model has average 72% SSA. We also discuss weaknesses of our methodology. Static evaluation is too restrictive to capture all aspects of human conversation. Nevertheless, the fact that Mina achieves such a high SSA score and then there is a correlation between SSA and perplexity means that a human-like chatbot in terms of sensibleness and specificity could be in a sight if we attain better perplexity. So they see that there could be some sort of human-like chatbot not too far away from this point in time. Our contributions are proposing simple human evaluation metric for multi-thing open domain chatbots that captures basic but important attributes of human conversation. 2. Showing the evidence that the perplexity is automatic metric that correlates with human judgment, in contrast to recent finding on other automatic metrics mentioned above. 3. Demonstrating the end-to-end neural model with sufficiently low perplexity can surpass the sensibleness and specificity of existing chatbots that rely on complex, handcrafted frameworks developed over many years. Evaluating chatbots. We describe human evaluation setup, static and interactive. So in static mode, the humans evaluate the conversations by reading them, and in interactive they actually ask the chatbot something. Measuring human likeness. Not being again, they speak about consistency. Of the sensibleness, they don't want to be too vague. Okay, on static evaluation, using fixed sets of prompts and bot generated responses, 70% of the generic bots responses are labeled sensible, surpassing even Diallo-GPT, 62%, even though Diallo-GPT is clearly more human-like than generic bot. To overcome this issue, we need our evaluation to separate more fully human-like conversation from bland and generic statements. Therefore, if a response is labeled as sensible, we further ask the crowd worker to determine if it's specific to the given context. For example, if I say a left tennis B response that's nice, then the utterance should be marked as not specific. That reply could be used in dozens of different contexts. However, if B responds, "Me too, I can't get enough of Roger Federer," then it's marked as specific, since it relates closely to what's being discussed. Sensitivity and specificity. Table 1. The average and a standard deviation of crowd worker agreement across static evolutions of Mina models. Each static evolution consists of 1477 pairs, each labeled by 5 crowd workers. So they agreed in 76% on sensibleness, and in case of specificity, they agreed in 66%. Which is not actually that much, it seems to me, but I guess it's not too little either. SSA versus human likeness. So human likeness is on the y-axis in percent, and SSA is on the x-axis, and we can see that there is a sort of straight line tendency where the if the bot is more specific, I mean if the conversationalist is more specific, then he becomes more human-like. So this is a sort of argument that this sensibleness, specificity, is actually very important. Yeah, so instead of judging sensibleness or specificity, however, we ask the crowd human workers to judge whether given a response human-like. Okay, let me back off a little bit. Yeah, specificity average, yes, SSA specificity average. Okay, so let's continue. Estimate of human performance, evolution of Mitsoku, interactive evolution, evaluation of Cleverbot, the DLGPT. To integrate with the Cleverbot, we leverage its API. For the LGPT, we use its open source 762 megaparameter model. It's worth mentioning that the initially tried 345 parameter LGPT model because it was reported to perform best on singleton human evolution. However, the 345 million parameter model seemed to perform noticeably worse than the 762 million, one of the preliminary values of multi-turn conversations. Our human evaluation is multi-turn, so we select 762 million model. The Dialog GPT authors were unable to release their decoding script at the time of the writing. Therefore, following their published description, we use top K decoding with K equals 10. Okay, they skipped the decoding evaluation of 2019. Since the backward was not released, we are not able to try their MMI ranking. Automatic evolution. For quick research iteration, we focused on Perplexity. Unlike the previous two evaluation types, the Perplexity is automatic metric. The seek-to-seek model outputs a probability distribution over possible next response tokens. The Perplexity measures how well the model predicts the test set data. In other words, how accurately it anticipates what people will say next. When interpreting Perplexity score, bear in mind that the lower is better and that the theoretical minimum is 1. As shown in section 4, this commonly used metric correlates with human judgment of sensibleness and specificity. This is encouraging because it's both automatic and directly optimizable with standard cross-entropy function. Okay. Mina chatbot. Okay, context response, model architecture, training data, in conversation they have training example from context response pair. We also filter data to improve generation quality. Message is removed if any of the following conditions holds. Number of subwords is less than 2, more than 128. The percentage of alphabetic characters is less than 70%. Message contains a URL, author's username, bot, Message is repeated more than 100 times. 6 messages high in gram overlap the parent text. The message is potentially unsafe or offensive. Respect the confidential text classifier. When a message is removed, we drop all subtree rooted under it. Mina contains 341 gigabytes of text, 40 billion words. In comparison, GPT read for 2019, 40 gig. Okay, so GPT-2 was trained on 40 gig, but here they have essentially 10 times more, 341 gigs. 40 gigs of internet. Okay, model architecture. They use evolved transformer seek-to-seek model with 2.6 billion parameters, which includes 1 ET encoder block, 13 ET decoder blocks. The evolved transformer is evolutionary NAS architecture. From 2018 and 17 based on transformer from 2017. Our largest maximum memory usage, evolved transformer, scored 10.2 Perplexity, and our largest vanilla transformer scored Perplexity 10.7 for the same number of training steps, 738K. The largest vanilla transformer had 32 decoder layers with other architecture hyperparameters held constant. For comparison, the extra large GPT-2 model has 1.5 billion parameters. So they have almost twice the amount of the parameters. Okay, responses for why do you like the ocean? So here Mina says, I love the beach. I like that it doesn't have anything in it, just open water. Or it's dark and mysterious. I discovered it when I was really young and it was a dream of mine since. The ocean is full of wonders, mysteries and great things to discover. I love snorkeling. I moved to Hawaii a year ago and I'm going to college for marine biology. So there's that. So that was table 2 sampling outputs. The response is followed by sampling with temperature sorted by length normalized log likelihood scores and using the same eval transformer as the one used in table 3. The scores are calculated as log p divided by temperature, where p is likelihood of the response and t is number of tokens. Okay. Beam search outputs, table 3. Top responses generated by beam search decoding and the corresponding cleft normalized log likelihood scores. We use evolved transformer with Perplexity 10.2. Vocabulary size of 8K. So they have 80,000 words in vocabulary. Why do you like ocean? Why don't you like the ocean? I don't like the ocean. I love the ocean. I don't like the ocean. I love it. Why don't you like the ocean? It's beautiful. Okay. Dialog GPT-2 has 762 million parameters. So so their model is really much bigger than the LGBT, so it's no big surprise that it's performing better. Training details, there's TPUs, 2.6 bar meter model can overfit. Well, okay. Decoding. In contrast, we show that the given model with sufficiently low perplexity, a simple sample and trunk decoding strategy achieves both diverse and high quality responses. For example, sample and rank works as follows. First, we sample n independent candidates' responses using plain random sampling with temperature T. Second, we select the candidate response with the highest probability to use as a final output. The temperature T is a hyperparameter that regulates probability distribution P of the next token during decoding. We divide the logit Zi by T, and before computing the softmax as hinted, so they here have a probability Pi is the exponent. It's basically softmax. Before computing softmax. Oh damn it! I jumped a little bit forward. Where was I? Okay, here. Table 2, responsive for arbitrary probing input. Why don't you like ocean? Okay, so I'm not sure now if they do. I guess they generate all logits and then they multiply the PIs to get the final score. Okay, I think that's all. Let's continue forward. Results. In this section, we will first demonstrate the correlation between test perplexity and human evaluation metric, as I defined earlier. We also include human-level upper bound estimates for both static and interactive evaluation. Beside the performance of other chatbots such as CLOIs, Mitsoku, Diablo GPT, and Cleverbot, lastly, we provide sample responses for different models given the same context to understand how Mina qualitatively compares to others. Let's say perplexity correlation. Okay, so this one, so this will be the figure 4. This is the section 4, and here there's this result about the correlation of SSA with perplexity. Basically claiming that the lower the perplexity, the more sensible and specific your bot will perform on human evaluation, and indeed from the figures it seems to be true. Really, there seem to be linear correspondence estimates. Sample context. You must have a lot of books. B. Oh wow! How do you know? Do I look nerdy? Of course you're not. Okay, I'm running long time, so we'll skip a little bit forward. Sample responses. Further advancing SSA. Cross-turn repetition example. Yeah, I think there they remove these repetitions from responses. Discussion. Okay, I think I'm gonna read the discussion and that's gonna be it. Discussion. Our results suggest perplexity on public domain social media conversations might be a good approximative proxy for human judgment of fundamental attributes of human likeness, such as sensibleness and specificity. The results also suggest that optimizing the probability of next token on large volumes of social media conversations can lead to human-like sensibleness in an open domain setting. However, our static evaluation dataset only contains one free-turn context, and it's based by the sources of the first turn and the fact that the two-turn free-turn context built on the shorter context. Our static evaluation dataset only contains one to three turn contexts, so those are biased, they say. Moreover, the contexts in these datasets are predominantly Turing test and social conversation style, including common sense, basic knowledge, and asking sharing about personality, likes, dislikes, opinions, feelings, hobbies, and pleasantries. This dataset does not include contexts like deeper conversation, question answering, basic math, and common sense tests designed to challenge machines but not humans. Human likeness is an incredibly broad and abstract concept. The interactive evaluation addresses some of the biases and scopes limitation in the static evaluation while still providing consistent score to quantify a given chatbot. Nevertheless, unlike static evaluation, it does not allow for granular comparison between different chatbot responses. In addition, it may be too short, 14 to 28 turns, and may assign too much weight to the typical beginning and ending of conversations. It may also be too short to cover deeper topics and exercise long-term memory. Furthermore, it may be necessary to expand the set of basic human-like conversation attributes being measured by beyond sensibleness and specificity. Some directions could include humor, empathy, deep reasoning, question answering, and knowledge discussion skills. One could also break down sensibleness in its implicit subcomponents: logical and personality consistence, common sense, relevance, basic factual correctness, and so on. Further work may explore the continuized optimization sensibleness via optimization of text set perplexity. That's all, and maybe see you next time. But before I go, I'm gonna do this one more thing. So I have this interesting application called Quiz Recall, which can be used to generate quizzes. You can copy paste and it will generate multiple choice questions for you. And I will do one quiz for myself regarding the main contributions of the paper, and I will just do a little bit of editing here such that the model is able to separate sentences. Also, I think there are some extra line endings, so I'll do this. Remove this extra, remove this one. Okay. Right, so I have the first questions and some title such that it's a human-like open domain chatbot. I would like to have a Mina in the title. So I like new and the ones human domain chatbots. I have the sentences in there. I will separate this one more sentence. And let's see. So we have 4 questions from the different sentences. I'll simplify the text a little bit further. Okay, so I have 4 questions, and then let's go. I have some fill in the blanks, and then I have these generated alternatives. And we can take a test on this. So Mina towards human domain-like chatbot, question 1. Our contributions are proposing a human-like evolution metric for multi-tune open domain chatbots that captures interactions between user of the bots, basic but interim attributes of a human conversation, emotion, storage, picture. So I guess it's 1A, yes. Showing the evidence that Perplexity is an automatic metric that correlates with human judgment, technical limitation, simple events. Yes, yeah, it's definitely human judgment. Showing evidence that Perplexity is automatic metric that correlates with. Alright, so I have the quiz. I will save it to Quiz Recall, and I will get notifications to refresh my knowledge, to test myself again on this. That's all. Thank you very much.